Simplify the square root of 72 minus 4 square root of 8 minus square root of 200. Now all these are in their complex form, so let's get their simple form. The square root of 72 will give us 6 root 2. Then minus the square root of 4 square root of 8 alone will give us 8 root 2. Since this one will give us 2 root 2, so the 2 will multiply the 4 to make it 8 root 2. Minus square root of 200 will give us 10 root 2. 6 root 2 minus 8 root 2 will give us minus 2 root 2. Since 6 minus 8 is minus 2. And it comes to root 2. Now, minus 10 root 2. So we'll still simplify. Minus 2 minus 10 is minus 12. Then the root 2. The final answer becomes minus 12 root 2. So if you simplify it, this is what you're getting. Thank you very much. Now this question also reads, simplify square root of 27 minus root of 12 minus root of 75. As usual, they are all in their complex set form, so we have to reduce them into their simple form. The square root of 27 can give us 3 root 3 minus the square root of 12, and in this simplified form will give us 2 root 3. Then we come to minus square root of 75 will give us 5 root 3. Now since they are all root 3, root 3, root 3, their sets are the same. So because the sets are the same, they are all like sets. So we can subtract them according to the signs in the question. So 3 of the root 3 minus 2 of the same root 3 will be 3 minus 2. So 3 minus 2 gives us 1 of the root 3. That is just a single root 3. Because 3 of the same root 3 minus 2 of the root 3 will give us just 1 of it. Now minus 5 root 3. So we say just a single 1 of the root 3 minus 5. Since the negative is affecting the 5, the answer will be negative. So negative 4 root 3. So this will be the final answer for this particular question. From this question, it reads, simplify the following. Root of 80 plus root 20 minus root 45. Now when we check root of 80, it becomes a complex set that we can simplify. So when you use your scientific calculator or you simplify root of 80, you should get 4 root 5. So in place of root of 80, we use the said simple form 4 root 5. Then plus root 20 can also be simplified into 2 root 5. Then finally minus root 45 will become 3 root 5. Now that they are all root 5, it means that they are all like sets. So we can now add or subtract them since the sets are the same. The reason why they are like sets is the square root of 5 is here, square root of 5 is here, square root of 5. So the sets in all the terms are the same, so like sets. Now 4 root 5, that is 4 of the root 5, plus 2 root 5, that is 2 of the root 5. So 4 plus 2 gives us 6, so we get 6 of the root 5. Then we'll come to minus 3 root 5. Now we come here 6 of the root 5 minus 3 of the root 5. We should get 3 root 5. So finally the answer for such a set will be 3 root 5. We want to take a look at properties of sets. Now we are about to multiply and divide sets. So we want to see how properties work for multiplication and then division when it comes to sets. Now without wasting my time, let's start with property number 1. So property number 1. Now property number 1 says that if a constant number or a real number is multiplying a set, then finally the answer can be written as the number square root of the other one. That is to say the number multiplying the set. So for example, a times root b becomes a root b. That means when a number is attached to a set, it is then multiplying the set. So an example can be 2 root 3. 2 root 3 means 2 times root 3. That is the meaning. So any number that is directly attached to a set becomes a multiplication to the set. Or in other words, the number is multiplying the set. So another example can be 4 root 7. And then 4 root 7 also means 4 multiplying the root of 7. So the set is 7. And then the coefficient of the number in front of it is 4. So that is how the set behaves in terms of a real number multiplying the set. in property 2, when a set multiplies the same set, that is the root of a number multiplying the same root of the number, the answer becomes the number. So root A times root A will produce A. Why is it like that? This is the reason. It is simple. The root of A times the root of A can now give us root of A multiplying A. So with this, we get root of A squared. And once the square root meets a square, it cancels out. So the final answer becomes A. So it is a simple phenomenon or a simple application for a set. Or this is again a property. So with this, if you have the square root of 2 multiplying the square root of 2, you should know that automatically the answer becomes 2. And also the square root of 5 times the square root of 5, it will become 5. So it is simple. The property states that when a set multiplies the same set, the answer is the number under the square root sign. So take note of this. The root of 5 times the root of 5, the answer will be 5. The root of 2 times the root of 2, the answer will be 2. Thank you. Now in property 3, the root of a number, that is the root of a set times the root of another set. When the sets are not the same, then the two numbers will multiply still under the square root sign. So it becomes the root of A times B, which will finally become the root of AB. An example will be the root of 2 multiplying the root of 3. Since the two sets are not the same and they are multiplying, we will then have the square root of 2 times 3. That means 2 will multiply 3. They are the numbers under the square root sign. So those two numbers will multiply still under the square root sign. And then 2 times 3 will give us 6. So the answer will become the square root of 6. So now this will become the set. So that is how it is. When two sets are multiplying, which are not the same, the numbers will multiply under the square root sign. Thank you. Now property number 4 reads, in case you have a real number, or let's say a number in front of a set multiplying still another number in front of another set. So like for example, m root A multiplying n root B. Here's how it's going to be. The real numbers or the coefficients will multiply. So m will multiply n. Then the sets will also multiply. So it will become root of A multiplying B. So at the end of the day, we have mn root AB. That is the meaning. So this property is for two sets all having coefficients in front of them. So an example can be 2 root 3 multiplying 5 root 2. Something like this. So you realize that the coefficient will multiply. So 2 times 5. And then the root of 3 times 2. So 2 times 5 will give us 10. Then the root of 3 times 2 will also give us 6. So we end up getting 10 root 6. So this is a typical example. That is property number 4. So take note of this property. So with property 5, we have the square root of A all divided by the square root of B. Now this is what the property says. We can rewrite this as the complete square root of everything. So this is what I mean. The square root of the numerator still divided by the denominator. Now, initially it was the square root of the numerator alone divided by the square root of the denominator. But don't forget that we can put them together with a single square root sign and the denominator divided by the, or the numerator rather, divided by the denominator. So this is it. This can be converted into this. So an example can be the square root of 3 over the square root of 2. Now the numerator is square root of 3, all divided by the denominator, which is square root of 2. This can be written as the entire square root of the top one, which is 3, over the denominator. So this can be converted into this. So this is what we call property number 5, or a set property. So these are the properties of the set under the multiplication and the division. So I'm going to make use of this in subsequent questions. Thank you. Now let us go deep into sets by looking at the multiplication of sets. And the multiplication of sets, the question goes like simplify the root of 8 times the root of 5. Now, as we taught you in the properties of set, these are two different sets which are multiplying. So we can go ahead and say the root of 8 times 5. We can put all the numbers under the set under one square root sign. And we know 8 times 5 is 40, so we can get the root of 40. And when you get the root of 40, you break it down from its complex nature into its simple nature. And the simple nature of root 40 will give us 2 root 10. So it means the answer for root 8 times root 5 will give us 2 root 10. Let us take another question. Now with this question it reads, simplify 2 root 18 times 3 root 20. Now, if you analyze this question well, you realize that there are sets with the coefficients or numbers in front of them. So if you are supposed to multiply these two terms, which are having sets and coefficients, we just have to multiply first of all the coefficient. So 2 multiply 3 first of all. Then we take the square root of the set. So the set 18 and the set 20 will multiply under one square root sign. So it becomes 18 by 20. So 18 by 20 alone will give us 360. So 2 times 3 is 6. And then square root of 360. So we have 6 root 360. Then the 6, as I said, comes from 2 times 3, which is 6. And then the 360 comes from 18 times 20. Now we get a square root of 360, which is supposed to also be a set. Now we are going to get 6 multiplying 6 and then the root of 10. Because 360 and then the square root sign, or the square root of 360 alone, gives us 6 root 10. Whereby the coefficient already 6, we also multiplying the new coefficient, which is 6. So 6 times the new coefficient, making it 6 times 6, root 10. And 6 times 6 itself is 36, root of 10. So with the final answer will become 36 root 10. So 2 root 18 times 3 root 20 will finally give us 36 root 10. Thank you. This question reads, simplify 2 root 3 into bracket 2 minus root 3 plus 3 root 2 into bracket root 2 minus 1. Now to simplify this, it means there are brackets and there is a coefficient against the bracket. So we expand the coefficient by the two terms or the binomials in the bracket. So 2 root 3 times 2 will give us 4 root 3. Then we get 2 root 3 times minus root 3 will give us minus 2 into bracket. Root 3 times root 3 will give us 3 this way. Then we have plus 3 root 2 times root 2 give us plus 3 into bracket. Root 2 times root 2 will give us 2. Then 3 root 2 finally times minus 1 will give us minus 3 root 2. Since any number times 1 is the same number, and this time around it's a negative 1. So negative 3 root 2. Now let's simplify. We get 4 root 3 minus 2 times 3 is minus 6 plus 3 times 2 is 6 minus 3 root 2. Now we have a positive of the 6 and the minus of the 6. So minus 6 plus 6 will cancel out, giving us 0. So it will remain with 4 root 3 minus 3 root of 2. Now if you check this very well, the said 4 root 3 is not the same as 3 root 2 or negative 3 root 2. So they are on like sets. So the final answer can be this way, or you can also write the final answer as minus 3 root 2 plus 4 root 3. So this can also be your final answer. These two answers are the same, just that the arrangements are not the same, but it's a commutative property where the negative can start, the positive term can start. So if you rearrange, you get the same term. So that is the meaning. And this question is giving us this answer. Thank you. This question reads, simplify the square root of 3 minus 1, all into bracket, then another bracket, 2 minus the square root of 3. Now we have two different brackets, so binomial terms in the bracket, so expanding binomial terms. Now with this, first of all, root 3 will expand these two terms in the second bracket. So root 3 times 2 will be 2 root 3. Then root 3 times minus root 3. Since root 3 alone times root 3 will give you 3, but the negative sign will come, so minus 3. Then we come to the number or the term minus 1. It will also multiply these two terms in the second bracket. So minus 1 times 2 will give us minus 2. Then minus 1 times minus root 3 will give us positive root of 3. Now the constants in the middle, minus 2 and minus 3, can be subtracted or can be combined. So we have 2 root 3, then this one gives us minus 5 plus root 3. We'll group like sets. The two sets are the same since they both have root 3, root 3. So 2 root 3 plus root 3 minus 5. Now 2 root 3, that is 2 of the root 3, plus just 1 of the root 3 will give us 3 of the root 3 minus 5. Since these two terms are not like terms, that means this root 3 and this has no roots. So this is a set, this is a constant, so we can't subtract the 2. But we can also write the answer as or minus 5 plus 3 root 3. There's also another way of putting the said answer. Both of them are the same. This is just a changing of the position of the terms, making a commutative property. So the negative term is starting in here, whilst the negative term is the second term. And then the said is a positive term starting here, but the said becomes the second term. So this question here gives us an answer of this one or that one. Thank you.